Hello everyone. So today I will be covering how to write a program in Ruby that can determine if a number is prime. So what we want a method that can be called that takes a number as an argument and returns true if the number is prime or false if the number is not prime. And in addition to showing you, how to write this, I really want to break the problem down. There's a few steps here to programming this pretty well. Once you're experienced, these steps will just come naturally, but since this video is geared more towards beginning programmers, I'm going to really break it down. Okay, so first, writing a method, we need to answer a few questions. What is the method called on? So remember, object-oriented programming. Ruby is an object-oriented language. We need to think, what is it called on? What arguments does the method take? What should the method do? And what is the return value of the method? Okay, so these are some questions we need to answer. For what it's called on, the way we're going to write it, it's just going to be called in general scope, not on any object. And I'll show you how we could write it to where it would be called specifically on a number. But in this case, the method is going to simply manipulate the argument it takes. So, takes a number as an argument. So we're going to pass it an argument, which will be a number, and it needs to test if this number is prime. What should the method do? Should simply analyze the number passed in to see if it is prime. Return value, true or false. Okay. So we've broken this down a bit. And it's good to use test-driven development. So let's talk a bit of what are prime numbers. A prime number is one where it can only be divided by one or itself. Okay, so prime numbers can only be divided evenly with no remainder by one or itself. Okay, so prime numbers, just for some examples here, I have a list of some of the first few prime numbers, so let's see. We can say 2, 19. Let's get some bigger ones, 67, and 181. Just give ourselves a few examples here. And then not prime numbers. 1 is not prime, it's special. Negative numbers. 100 is not prime, divisible by 2, 50, and many other numbers. And let's see, just for good measure, we'll include one more. How about 22? Okay, so for these prime numbers, should return true. And these should return false. Okay. So let's start writing our method then. by convention in Ruby, a method that returns true or false should end with a question mark. So we use the keyword def to define it, and it will take an argument of a number. And now, when you start writing a method, you got to know what you're actually doing first, what the method should do. And I like to start with a pseudocode. So just think, if you're a human, how would you determine if a number is prime? Well, the first thing you would do, you would see, is it a whole number? That would mean should return false if a decimal. Decimals are not prime numbers. Next you would see, is it less than 2? Should return false if less than 2. Next, 2 is kind of a special case because there's only one whole number before 2, and that's 1. So 2 is only divisible by 1 in itself, but it's not a prime number. Or excuse me, it is a prime number though. We define it just by definition that it's the first prime number. So should return true if the number is 2. All right, but what about larger numbers? So let's just say I gave you a number 11, and you say, okay, well that's prime. How you would prove it is you could test every number from 2 until 1 less than the number and see if it divides it evenly. So 11 divided by 2 has a remainder, 11 divided by 3 still has a remainder, and so on. And so we can conclude the number is prime. And there are better algorithms, which I'll show later, but this really, just for starters, we'll use that as a pseudocode. So we're going to test if the number can be divided evenly by any integer from 2 to 1 less than the number. Okay. And should return false if yes. If no number divides it evenly from above, it should return true. Okay, so those are the operations we would perform here. We just now need to tell the machine how to do this. So let's go over that. So first statement, so is it a whole number? Should return false if a decimal. So we'll just say return false if, now there's a nice little Ruby method called integer question mark. And if number.integer question mark is false, then it should return false. So we could just say if it equals false. But a nicer syntax is to just put the exclamation mark here. Okay, so that's our first step here. Just to show you how that works, I'm going to get into IRB here. So we have a clean Ruby environment. And just to show you what will it return if we call integer question mark on 5.5? Well, it's false because 5.5 is not an integer, it's a decimal. 5, on the other hand, is an integer, so that's true. Now, of course, that doesn't mean that it should return true if the number is an integer, because not all integers are prime. But this is our first step of just weeding things out. Okay, next step. is it less than 2? And it should return false if less than 2. And by the way, we're using the keyword return because that ends the method and forces the return value. We don't have to do anything else if we've concluded that the number is not prime. We should just immediately return false. So we will return false if the number is less than 2. We use the little less than sign operator. And we can condense this syntax down later, but just for illustrative purposes, we'll keep it simple for now. Next one should be true if the number is 2. So return true if number equals 2. Okay, and remember the double equal sign is the Ruby comparison operator. So that's saying return true if the number is 2. All right, and the next one is a little bit trickier here. So we need to test if the number can be divided evenly by any integer from 2 to 1 less than the number. And here's how we would do that. We're just going to give it a range. So in parentheses, we're going to put 2 dot dot, and now 1 less than the number. Okay, and I'll show you in IRB what this means. So let's just assign a number here. We'll say the number equals 20. And now to make a range of 2 to the number, we can just say we want 2 to number minus 1. So that's 2 through 19. And we can call an enumerator method like dot each. And now I'm going to have it print all the different numbers. There we go. We have 2 through 19. All right, so I'm going to break this down some more. We're going to call dot each. This is an enumerator method that loops over that entire range. So when we use a method like this, we put what's called a parameter variable in pipes, and that's going to represent every element. And we can call that whatever we want. I'm just going to call it, num and number. That can be a little confusing. Let's just call it int for every integer in that range. And now what that is, int is going to be every one of these one at a time. So starting at 2, 3, 4, 5. In the loop, it's going to go over each of those. And then what we want to say now, we want to say, return false if the number can be divided evenly by that integer. And there's a special operator, the modulus operator here, that specifically gets the remainder. And I'll show you that in IRB. So let's say, for instance, we have 4 modulus 2. This is going to be 0 because 4 divided by 2 just divides evenly, and you can take out 2 from 4 2 times with no remainder. Okay, just another demonstration. How about 15 modulus 3? 15 wouldn't be prime because 3 divides it evenly. On the other hand, 11 is prime. If we try 11 modulus 3, we have a remainder of 2 because you can take 3 from 11 3 times. That's 11 minus 9 with a remainder of 2. Okay, so that should work right there. Let me put that, I'm just going to put this lined up with the pseudocode comments here. All right, and if no number divides it evenly from above, it should return true. Because if we make it through this entire loop without finding any integer that divides it evenly, we can now conclude the number is prime, because it passed all these other conditionals. And since this is the last line of the Ruby method, we don't have to put return true. We can just do true, because that'll be the return value of our method. Now we'll just end that. And this here should work. And what we'll do, we're gonna test it out a little bit. So let's remind ourselves what our prime numbers are. And again, let's comment this out. We don't want this executed as code. We just want to have some comments here in the Ruby file. And remember, the Ruby comment is the number sign here. So it will not execute these lines. They're just comments. Okay, so if we call is prime on any of these numbers, it should return true. So we're going to puts make it quicker, we'll just copy and paste these. All right, 67 and 181. All right, and then for these ones that are not, so we have 1, -5. You know what, let's just add a decimal just for good measure. Okay, so we have our definition here. And in the main scope of this file, main scope meaning it's not within a variable or a method like is prime, we're just putsing out the result of a call to the method and an argument passed in. So let's see what it does. We're going to exit from IRB. Let's run Ruby is prime. And there's the output. So the first 4 are true, last 5 are false. So these should all be true, which they are. And these 5 are false, which they should be. So our method works. And in the next video, I'll break this down a little more and explain what programming concepts are needed to successfully do this.